Graph transformations. There are four graph transformations we need to consider. Y is equal to a times f of x. A here is just a number multiplying f of x. Y is equal to f of bx. B is a number which multiplies x directly. Y is equal to f of x minus c. C is a number subtracted from x directly. And y equals f of x plus d. The d is a constant, or just a number, being added to f of x. In the notes we've dealt with y equals f of x plus d first, and that's because it's the easiest of the transformations. So let's suppose that our function is x squared here. The blue curve is y equals f of x, y equals x squared, which you should know. If we look at the pink curve, it's the blue curve moved down by 5 units. Look at some reference points. So if we look at the origin here, that's moved to here, which is a distance of 5 units. If we go to this point here at 2, 4, then once again that's moved down by 5 units. So the pink curve is just the blue one moved down 5 units. And we could look at another point over here as well. The pink curve is y is x squared minus 5. F of x minus 5 is f of x moved down 5 units. Now you have to use the right words here. If you use that, you won't get the marks in the test. You have to say translated 5 units down. In general, f of x plus d is f of x, remember to use the word translated here, d units vertically. Now it's important to note that we'll be looking at each of these transformations at length in the examples. So we're just giving an overview here. So we're going to consider a times f of x next. So we're going to let f of x be x squared, and the blue curve is y equals f of x. If we look at the pink curve, it's the blue curve stretched vertically by a scale factor of 3. We can see this by looking at some reference points. So if we look at these 2 points here, this one is 2, 4, this one is 2, 12. So the y-coordinate has been multiplied by 3. Over here, if we look at these 2 points, this one is negative 3, 9. This one's negative 3, 27. So once again, the y-coordinate has been multiplied by 3. The pink curve is y is 3x squared. 3 times f of x is f of x dilated by a scale factor of 3 parallel to the y-axis. Now this is the correct terminology, dilated, not stretched. Parallel to the y-axis, not vertically. So make sure you use this language. In general, a times f of x is f of x dilated a units vertically, or parallel to the y-axis. Note, with both of these transformations, the constant a or d acts outside of the function. So here we can see the a multiplying the f of x. In the previous transformation, the d was added after we'd computed f of x. With both transformations, the change is vertical, affecting only the y-coordinates. So we can see here, x-coordinates the same, y-coordinates changed, and the same here. If a is negative, here we just looked at a positive value, 3, we get a reflection in the x-axis. Now, if a is negative 1, it's exactly a reflection in the x-axis, but we also get a dilation if x is not negative 1. So the curve would appear down here. Now let's consider y equals f of x minus c, and this is the first of the transformations we're looking at where the constant acts directly on the x rather than the function as a whole. So we'll look at f of x is x squared, and the blue curve here is y equals f of x, y equals x squared, and then we've got the pink curve here as well. Now, if we look at these 2 points, we can see that this has moved from 0, 0 to 3, 0. So it's moved 3 units across to the right. If we take another pair of reference points, such as here, we've gone from 416 to 716. So the x-coordinates changed, it's increased by 3. And the pink curve is y equals x minus 3 all squared. Now note this is a minus inside here, but it's moved to the right. It's moved a positive 3 units. F of x minus 3 is f of x translated 3 units to the right. In general, f of x minus c is f of x translated c units to the right. So if this is a negative c in here, it's going to move to the right. If you had a plus something, it would move to the left. Finally, let's consider y equals f of bx. And once again, notice the b is applied directly to the x, not to the function as a whole. Now, x squared itself is not a very good function for looking at this one, so we're going to look at x squared x minus 4, which is a cubic. The blue curve is y equals f of x. Now if we take a reference point here and here, we can see this one is 4, 0, this one is 8, 0. X coordinates have changed, y coordinates haven't. Here's another reference point. So that's 525. This one is 1025. Notice that the x coordinates have doubled. The y coordinates have not changed. The pink curve is y is 0.5 x squared, 0.5x minus 4. F of 0.5x, therefore, is f of x dilated scale factor 2, that's because the x coordinates have doubled, parallel to the x-axis. In general, f of bx is f of x dilated parallel to the x-axis, scale factor 1 over b. Note with the second pair of transformations, the constant b or c acts inside of the function, i.e. it's applied directly to x. We pointed that out as we went through, but we can see here the 0.5 is multiplying x every time there's an x. With both transformations, the change is horizontal, affecting only x coordinates. If b is a negative number, we get a reflection in the y-axis. That's not surprising because this affects x coordinates, combined with a dilation if x is not equal to negative 1. So if x is negative 1, it would just be a straight reflection in the y-axis.